Okay, in this video we're going to look at solving equations that have trig functions in them. And we're going to take before we do that, we're going to take a brief review of solving equations. Maths is all about problem solving. We use logic to break down complex problems, we find solutions to these, and then we communicate our solutions to others. We convince others of the validity of our solutions by sticking to an agreed set of ideas and rules. That is, we use the same number system, we use the same algebra, and as we solve more and more complicated problems, we find that we have to develop not just more and more complicated techniques, but we also have to develop our number system to cater for the kinds of solutions that we need to have to solve all of these problems. Initially, when we start, the equations are relatively simple. So an equation like x plus 2 is equal to 5. I mean, that's the kind of thing we can do in our heads. We know that the solution to that is x equals 3, for example. Well, that is the solution, it's not an example. Those kinds of answers are nice whole numbers, and hence, the original number system that we had would have been just whole numbers. We would have had to expand that, as we would come across equations like the second one, x plus 7 is equal to 3. Solution is not a nice, well, it's not a positive number. We had to introduce these things called negative numbers, x equals negative 4. Then we've got ones that involve fractions. 5x is equal to 2. Solutions, x equals 2/5, not a whole number. So we're starting to fill in the gaps between the whole numbers. And then instead of having newer numbers, newer kinds of numbers, we're finding that the kinds of problems that we have to solve get a little bit more complicated. So for example, you'd come across something like 3x plus 2 is equal to 6, where we have more than one operation happening, and we've got to use a series of techniques to solve and find the unknown value x. And we find that, again, just like the previous one, it is a fraction, x equals 4/3. And then a couple of years ago, most of you would have come across equations that have powers in them. X squared minus 6x is, well, plus 8 is equal to 0. And we come across this new idea of having more than one solution. So instead of just one number, whether that's a negative or a fraction, we now have two solutions. Right? So it's not just one solution, there's two, x equals 2 and x equals 4. Those kinds of ideas are the things that we are going to look at when we look at trig functions. So, the example that you were given in the do now is tan x is equal to 1. Yep. So we're looking for values of x that make that true. You'll also find that the way that these equations are written, the letters that we use for the variables, for the unknowns, will change depending on what kind of solution we're expecting. So in the case where we are trying to work out an angle, as in these kinds of problems, 10x is equal to 1, for example, we know that the x will be an angle. It's either going to be in radians or degrees. Often we will replace that with a theta rather than a generic x. Instead of writing tan x is equal to 1, we'll say, well, tan theta is equal to 1 and find theta. Theta is going to be an angle. And you'll find that for those of you who opt in to do the complex number standard, you'll find that similar sorts of things happen when we're dealing with answers that we expect to be complex, expect to have imaginary parts in them. So instead of using sort of x again, we'll replace that with a z. Z's the default for complex numbers. Alright, so let's go back to the problem that we had initially. Tan x is equal to 1. And we're looking for solutions to that. So, what values of x will make that true, essentially? Well, we know that one of the values is going to be 45 degrees. Yep. We can test that. We can say, all right, let's just see whether or not that's true. So let's just punch that into our graphics calculator. We say, all right, what's the tan of 45 degrees? Yep, it's 1. So that is true. In fact, we can actually find what that angle is by using our calculator. So we could say, well, just tell us what the inverse tan of 1 is. And, yep, it tells us that that's 45 degrees. So that at least gives us one answer. However, we know that there are other solutions to this as well. So for example, I know from experience that the tan of 225 degrees is also 1. Alright, don't believe me? Let's have a look and see. So tan 225. Yep, that's also 1. In fact, I also know that the tan of 405 degrees is also 1. Let's see if I'm fibbing. So tan 405. Correct? That's also 1. So, how many solutions are there? And, more importantly, can we describe these solutions using a formula? So in order to do this, we need to look at the graph of the tan function. Okay, so here is the graph of the tan function. We can see it has a period of 180 degrees. Right, we can see that curve repeats itself every 180 degrees. We can see that for the tangent to be equal to 1, one of the angles is 45 degrees, halfway between 0 and 90. We can see the second solution that I talked about, 225 degrees, is also there, as well as the third solution, which is 405 degrees. We can see that these answers are 180 degrees apart. We can actually use that first angle that we found using our calculator to find every single solution by just applying that simple pattern. Right, so for example, if we say that, right, so that was our first solution, 45 degrees. This second solution here is just 45 degrees plus 180 degrees. This third solution is 45 degrees plus 2 lots of 180 degrees. So we can predict what the third one is going to be. That one there is going to be 45 degrees plus 3 lots of 180 degrees. We can also see it goes in the other direction as well. We can subtract 180 degrees to find other solutions on the left-hand side, on the negative part of the x-axis. So this one here, the one before 45 degrees, is 45 minus 180. And then the next one along, this one here, would be 45 minus 2 lots of 180 degrees. We can see that there is a pattern, right? If we look at these expressions that were written down for each of these formulas, we can see that each one of them has the 45 degree bit, which is that first solution that we found by punching in, inverse tan of 1. And then from that, we can build and work out all of the other solutions. In fact, we know how to work out a formula for that. We can say that the general solution is going to be this thing. 180 degrees times n, where n is an integer. Yep, -2 there, -1 there, and this one here it's 0, and this one here it's 1, and this one here it's 2. So it goes -2, -1, 0, 1, 2. Yep, those are all integers. 180 degrees times an integer n plus whatever the original solution was, this thing here, right? whatever that is, which is the principal solution, alpha. All right, so that's a new term you learned. Principal solution, the original solution. So 180 degrees n plus alpha. And then if you are using, instead of using degrees, if you're using radians, you'd write that as, instead of 180 degrees, you just replace that with pi. Pi n plus alpha. And often you'll find that your formulas will have the n coming before pi, even though pi is a number, because it's written as a letter. It's a funny letter. It's a Greek. It's part of the Greek alphabet. Pi is p. P comes after n, which is why we have n pi rather than pi n plus alpha. All right. So all really we need to do is work out that first one, that first principal solution, to find this general solution. So this is what's called a general solution. And then from that you can work out every single possible solutions if you're asked to work out all the solutions within a particular domain. Okay? So for example, if you were asked to find all the answers to this problem, tan of x is equal to 0.5, and you're asked to work out all the values of x between 0 and 360 degrees. Yep. What are all the values of x that make this thing here true for x between 0 and 360 degrees? Alright, so the way that you do that is, alright, in order to do that, I say, well, I know what the general solution is going to be. It's going to be x is equal to 180 degrees n plus alpha. I just need to work out what the alpha is. The alpha is the inverse tan of that number. Use my calculator for that. I go shift inverse tan 0.5, which is 26.6 degrees. I then put that into my formula, so that's 180 degrees n plus 26.6 degrees. And then I just cycle my way through all the possible values of x. So I say, alright, if I start with n equals 0. So this, by the way, is your general solution. And then what I'm finding is all the particular solutions that satisfy this extra criteria. Alright, so n equals 0, x0 is, well, what's x0? Well, that's going to be 0, because anything times 0 is 0. And I'm just left with the 26.6 degrees. Is that between 0 and 360 degrees? Yes, it is. So that's a solution. If I go n equals 1, I've got x1, that's going to be 180 degrees plus 180 degrees times 1 plus 26.6 degrees, which is 206 degrees, 0.6. Is that between 0 and 360 degrees? Yes, it is. If I go n equals 2, x2 is 180 degrees times 2 plus 226.6 degrees. Well, I know that's going to be more than 360 because this is 360, and then I'm adding more to it, so I don't even have to worry about working that out. I know that that's not going to be a solution. What if I go the other way? What if I say, well, what about n equals -1? So x -1, what's that going to be? That's going to be 180 degrees times -1 plus 26.6 degrees. Well, I know that's not going to be within my domain, right? 0 to 360, because that's going to be a negative number. Yep. So that's, I don't have to worry about that. So there are only two solutions. So the solutions are x equals 26.6 degrees and 206.6 degrees. Wow. And we'll do a few more of those in a little bit more detail and less messy than what I've done here later on.